So welcome to your first video lesson. This is for lesson 1.1 on expressions and variables. The best way to go about this, or one way to go about it, is to watch the lesson first. Feel free to pause or rewatch any sections as needed. As you watch it, you should take notes in your math rules notebook, but you don't have to include all the practice problems, but at least include the example problems. Then you should also complete any practice problems that are within the lesson and bring any questions you may have about the lesson to class tomorrow so we can review the most difficult points. We will be using lessons like this and similar to this throughout the year. They won't be every night, but we'll see how it's working for us. One of the benefits is if you're absent, you haven't missed a lesson. You have the lessons at home and on the computer. And also when it's time to review for a test or quiz, you can go back and rewatch the lessons for greater practice. So there's a few new things that we're going to learn in lesson 1.1 on expressions and variables, and maybe it's review. But to start, there's a few vocabulary words. And the first is numerical expression. And what a numerical expression is when you have two numbers and you have some kind of operation such as addition, subtraction, multiplication, or division between them. At this point, you should know how to solve this type of problem, but you should remember your order of operations. So remember, you do your parentheses first, then exponents, multiplication, and division in order from left to right, and then subtraction and addition in order from left to right. So that's a numerical expression. But now that we're starting with our pre-algebra course, we're going to be working with variable expressions. So an example of a variable expression is one of these expressions that actually includes a variable, which is the letter portion that's representing one or more numbers. So in this case, we have 95 plus x, where x is our variable. And we can solve and evaluate these expressions by substituting a number for each of the variables. So in this case, we have 1. So an example, evaluate the above variable expression when x equals 10. So we can plug in 10 for x, so we get 95 plus 10, and that's equal to 105. So this is the difference. The variable expression will have a variable in it, or numerical expressions only have numbers. And a third vocab word, and this comes into play when we're doing word problems, and I'll give you a further example. So this is a verbal model. So if they tell you in words the difference of 17 and a number, you are going to have to be able to take that verbal model and write it as a variable expression. So we want to take this and bring it over to our variable expression. So here the difference of a 17 and a number can be written as a variable expression by using 17 minus x, because the difference is telling us it's subtraction. So let's do an example. So here you have $120 in your bank account. You can evaluate the expression 120 plus d when d equals 28 to find the amount you have in your bank account after you deposit $28. So we can go ahead and write this 120 plus d, but in this case they're telling us that you deposited $28. So d is equal to 28. So now we can substitute the numbers. So 120 plus 28, we can then solve and get $148. So now I want you to press pause and try these equations below and bring them with you to class tomorrow. So there's 5 questions, 1 through 5. Press pause now and work on them on your own. So for example 2, we have evaluating expressions that have 2 variables, meaning 2 different letters. So we have A and B, where A equals 6 and B equals 18. Press pause now and try A, which is B minus A, and problem B, which is B divided by A, on your own. So now you see that we can rewrite B minus A as 18 because b equals 18, and minus 6 because a equals 6. And then we can easily solve this numerical expression, which is equal to 12. We also have this b divided by a, so 18 divided by 6 is equal to 3. Now complete the following 3 problems. Use when x is equal to 14, y equals 7, and z equals 4, and bring them to class tomorrow. Remember, whenever you have 2 variables next to each other, here, that's actually the same as x times z. So a lot of times now in pre-algebra, we won't use x as a multiplication symbol because sometimes x can be the variable. So we'll either use a dot or no symbol at all. That's multiplication. And the last example for this section is writing a variable expression. So read the word problem alone below on your own, and I'm going to read it to you as well. So Grove City, Pennsylvania received 5 inches fewer of rain this year than it did last year. Use a verbal model to write a variable expression for the number of inches of rain Grove City received this year if you know the number of inches of rain Grove City received last year. So try on your own now, press pause, and figure out how would you write this as a variable expression and verbal model. So here, I started by saying n is going to represent the number of inches of rain Grove City received last year. And the word fewer indicates subtraction. So I can write this as inches this year is equal to inches last year minus 5, or n minus 5 would be my variable expression. Try to write the following 2 problems on your own and bring them in tomorrow for homework. And that's the end of our first video lesson. Please bring any questions you have about any of the types of examples or problems with you to class tomorrow so we can address them together.